Okay, so the aim of these first set of lectures is to introduce a general approach to making decisions, and particularly in the context of trying to use data to distinguish between two different classes. So before we look at the parts of this problem in detail, I want to give you a kind of a high-level example. So imagine you're trying to develop a system that's going to classify email as either spam or not spam. Sometimes people call it ham. So you want to classify your email as spam or ham, and you want to make a decision for each email whether to put it in the inbox or whether to put it in the spam folder. So that's the decision you're trying to make. And so the data that you have is the contents of the email itself. Maybe you have information on the headers, etc., but particularly maybe think about the words in the email. So think of that as the data. And so one way of trying to start to build a spam filter would be to develop a model that tries to distinguish between whether an email looks like spam or looks like ham. So you can imagine building a model that was based on, for example, which words occur. Some words are more likely to occur in spam, some are more likely to occur in ham. And so that's one part of the decision process, if you like, is a model that for any given email will give you some indication, some quantitative indication of whether the email looks more like spam or ham. And that's the likelihood part of the problem. Or that's going to be the likelihood part of the problem. But when you then come to decide whether an email should actually be put in the inbox or in the spam folder, there are more things to consider than just whether the email, based on its words, looks like spam or looks like ham. So there are actually two other components to the decision problem. The first is, well, what proportion of emails are spam versus ham? So if most of the emails are spam, most of the emails you're looking at are spam, then the intuition is that you're going to have to be more stringent about deciding something is not spam in order to avoid putting a lot of spam in the inbox. So that's so if you've got an email that looks slightly less like spam than like ham, but you know that most things are spam, then probably the email's still spam. That's the intuition. The second component of the problem is how much do you care about different kinds of mistakes you might make? So that's the loss function part of the problem. So for example, there are two types of mistakes you might make in this problem. You might put spam in the inbox, or you might put ham in the spam box. So those are both mistakes you might make. And some people might care more about one of those mistakes than others. So most people are pretty worried about putting real mail in the spam and missing it. And that might be more problematic to them. They might prefer to make a few mistakes the other way, where there's a little bit of spam in their inbox, rather than miss an email that is actually important to them. So if that were the case, then you might say your cost or your loss for misclassifying a spam email as mistakenly putting it in the inbox, that the cost of that is maybe lower than mistakenly putting a real mail in your spam folder, which you might consider more of a bigger mistake, if you like. So that's where the loss function part of the decision problem is going to come in. So once again, just to summarize, there's going to be kind of three parts. We're going to think about making decisions and dividing parts of the problem into, or dividing the problem into essentially three parts, kind of building a model, a likelihood-based model for what might look like, in this case, spam versus ham, and then incorporating prior information about what proportion of emails are spam versus ham, and then also incorporating how a loss function that captures how much you care about making different types of mistakes. Now, we're not going to do it in the context of email because building the likelihood part of the email of an email model is kind of a bit too complicated. So to illustrate these ideas, we're going to use some simpler examples, but you can kind of break down any decision problem into these, or you can try to break down any decision problem, and it's often useful to break it down into these three components. To give you another example that's going to come up later, maybe there's a simple diagnostic test you might perform on someone to see if they have a particular disease. So you have a string of patients arriving at your door maybe, and you conduct this diagnostic test, and the test has some result if you are diseased, and some result if you're normal, but maybe the potential results overlap something. So you don't get a definitive diagnostic from the test. You only get some statistical information, and we'll want to quantify that statistical information in the likelihood. But then if you actually decide whether someone's diseased, and maybe you're going to treat them if they're diseased versus normal, in which case maybe you're going to say go home and we stop worrying about it. We have to incorporate not only the information from the test, but two other pieces of information. What proportion of people who you're giving the test to are actually diseased? So that would be the prior part. And what's the relative costs of not treating someone who is actually diseased, or of treating someone who's actually healthy? So both those might be mistakes. And so that would be where the loss function comes in. So you can see you've got to start thinking about problems, trying to think about, well, where does which part's the model, which part's the prior information, and which parts are related to the costs or losses of making particular mistakes. Okay, so that's a high level view, and now we're going to look in more detail at some of these, at these three different components.